Indium phosphide quantum dots are an exciting material for emerging and future optoelectronic technologies. Both academic and industry research labs are in need of high-quality indium phosphide quantum dots.
The indium phosphide cluster prepared with this material is an atomically precise and robust precursor for many nanoscale applications, and it can be efficaciously synthesized on the gram scale.
Demonstrating the procedure will be Andrew Ritchhart and Nayon Park, 2 graduate students from my laboratory.
To begin, place 2.65 grams of myristic acid in a flame or oven-dried 50 milliliter 3-neck round-bottom flask equipped with a stirrup bar and connected to a Schlenk line. Put the flask under vacuum and refill it with nitrogen gas 3 times. Then, evacuate the flask and heat the myristic acid to 110 degrees Celsius while stirring at 200 rpm. Continue stirring under vacuum for 2 hours to remove water. Next, place the flask under a positive flow of nitrogen gas, turn off the heat, and add 0.93 grams of indium-3 acetate. Evacuate the flask, turn the heat back on, and start stirring the mixture at 500 rpm. Once the mixture is completely liquid, continue stirring at 110 degrees Celsius under vacuum for 6 to 12 hours to obtain indium-3 myristate. Then, in a nitrogen-filled glove box, fill a syringe with 20 milliliters of anhydrous toluene. Refill the reaction flask with nitrogen gas and add the toluene from the prepared syringe. Confirm that the solution begins refluxing. In the nitrogen-filled glove box, combine 465 microliters of tris-trimethyl.